welcome back. So, guys, I am now on check understanding number two on page 423. Now, we are going to be determining the trig ratios of all the angles that have 30 degrees as a reference angle. Now, before you do this, I would like you to watch the video that I made wherein I showed how to derive or how to determine the different trig ratios for the 30-degree, 60-degree, and 45-degree angles. Okay? It is in a separate video, so I'm going to post it also. So if you haven't done that, please stop. Please pause this video and watch that instead, and then just come back for this. Okay? Now, if you have watched that one, you would have an idea of what the um, uh, different trig ratios of a 30-degree angle would be. Okay, so to recall what I just did there, the cosine of 30 degrees would be what? The cosine of 30 degrees is root 3 over 2. Okay, once again, if you don't know where that came from, I'm guessing that you haven't watched the other video that I made. I really want you to watch that because you have to understand where the root 3 over 2 came from. While the sine of 30 degrees would be 1/2, okay? And the tangent of 30 degrees is what? 1 over root 3. Now, you will see that I created a picture here wherein there are four reference angles, all of which are 30. The first one, this one, and it is, as you can see, measured from the x, positive x, okay, this way, up to this terminal arm. That's 30 degrees. This is quadrant 1, right? This one here, quadrant 1. And in quadrant 1, the reference angle is also 30 degrees. And the angle standard position is also 30 degrees, right? So if I fill this out, the angle standard position is 30 degrees. The reference angle is the same. Now in quadrant 2, which is this one, okay, the reference angle is 30 degrees also because again, this it's this one. And the reference angle is that angle wherein you measure beginning from the x-axis until you get to the terminal arm and it goes that way, all right? Now, if the reference angle is 30 degrees, what is the angle in standard position? The angle in standard position would be that angle that would be starting from the positive x, so going this way. There you go, that's the angle in standard position. So if you make a full turn, right, from here to here, that is 180. Therefore, if you only reach up to here, that means that is 180 minus 30, right? Which is 150 degrees. Okay. All right. All right. So no, I have to do this first so that the blue would go away. All right, 150 degrees. There you go. What about in quadrant 3, wherein the reference angle is 30 degrees and quadrant 3 is where? This is quadrant 3 right here. The reference angle is this one. Yep. Okay. But the question is, what would be the angle in standard position? So the angle in standard position would be the angle that starts from the positive x until you get to this one. And that would be what? From here to here, that's 180. You add 30 more. That means that is 210, right? 210 degrees. While in quadrant 4, this one, quadrant 4, all right? The reference angle is this one. But then the angle in standard position would be this one here, going all the way through. And if you make the full turn, That's 360, but then we only end here. That means it's 360 minus 30. That would be 330 degrees. Now, how do you make use of the reference angle again? Why did I even bother to write all of these? Because, guys, the trig ratio of these angles here would have the same values as these ones, except that they would probably have different signs depending on which quadrant it is gonna be. Okay? So, in quadrant one, wherein all of the trig ratios are positive, cosine of 30 is root of 3 over 2, right here. Sine of 30 is 1 half, right here. Tangent of 30 is 1 over root of 3, right here. Now, what about in quadrant 2? So this is quadrant 1, okay? Because it says determine the trig ratios of all the angles that have 30 degrees as a reference angle. So in quadrant 2, okay, oops, what would be that angle that would have 30 degrees as a reference angle? We already saw it right here. The reference angle is 30 degrees. The angle would be 150, right? Therefore, the cosine of 150 is going to be root of 3 over 2 also, but we have to ask ourselves, since it is in quadrant 2, is cosine going to be positive? All right? So ask yourself, is cosine going to be positive for 150? The answer is no, it is going to be negative. Well, but what about the sine of 150 degrees? The sine of 150 degrees, since it has the same reference angle as 30, is also going to be 1 half. But you ask yourself, what is this, the sign, meaning is it positive or negative, of 150? Since it's in quadrant 2, the sign ratio is positive, all right? Positive 1 half, you don't really write the plus, okay? What is the tangent of 150? So again, it is going to share the same trig ratio because it has the same reference angle. It's going to be 1 over root 3. But then the tangent in quadrant 2 is going to be negative. Okay. So guys, what do you notice? The values, the absolute value, or the number only, if we put it that way, of the ratios are really the same. Cosine of 30 is root of 3 over 2. The cosine of 150 is root of 3 over 2 also, except that it's negative. The sine is 1 half. The sine is 1 half. They are both positive. While tangent is also 1 over root 3 for both, except that in quadrant 2, it is negative. So perhaps I think you already get the idea that the reason why we need the reference angle is that it makes it easier for us to figure out what the primary trig ratios are of those angles that have the same reference angle. Okay, so let's go to quadrant 3. Quadrant 3, which has a reference angle of 30 degrees, the angle is 210 right here. So cosine of 210, and I think you already got the idea. It would have the same value as this one, right? Except that we need to ask ourselves, is the cosine in quadrant 3 positive or negative? And we have seen, and already know that it's going to be a negative in quadrant 3. What about the sine of 210 degrees? The sine of 210 degrees would be the same as this one, 1 half. But we ask ourselves, is it positive or negative? And the sine in quadrant 3 is negative, all right? While the tangent of 210 degrees would be the same as this one, all right? Except that we ask ourselves, is it positive or negative? And in quadrant 3, only the tangent is negative, according to the cast rule, okay? quadrant 4. Okay, so what is that angle? That has a reference angle of 30 degrees, okay, which is going this way. We already have a list here. It's 330. Therefore, what is the cosine of 330? It's going to be root 3 over 2, except that we ask ourselves, is cosine in quadrant 4 positive or negative? And it's going to be positive, all right? Okay, so it remains as root 3 over 3, root 3 over 2. What is the sine of 330? It's going to be this one, except that we ask ourselves whether it's going to be positive or negative. And the sine value in the fourth quadrant is negative, okay? While the last one, tangent of 330, will also be this one, but then we ask ourselves, is it going to be positive or negative? And in the fourth quadrant, tangent is negative. So, in summary, the reason why you have to get the values for the reference angle is that it will give you all the trig values for those angles in standard position that have the same reference angle. All you have to do is to ask yourself what adjustments to the sign of the numbers you have to do, um, depending on what quadrant it is that your angle will be terminating in. Okay, so I hope that makes sense. um, I know that's for some of you it might be a little bit too much, so again, I recommend that you stop the video, you pause it, go back, watch this again. Okay, all right, check your understanding. Number 3. Okay, to the nearest degree, which values of theta satisfy the equation tangent theta is equal to negative 4/3 for 0, or for theta between 0 to 360. Now, let's put it this way. If tangent theta, all right, tangent theta is negative, what does it tell us about the about where the angle would be? All right, in quadrant 1, tangent is positive, right? Tangent, quadrant 1, tangent is positive. In quadrant 2, oops, tangent is negative. Oh, so it seems that we have at least one answer which should be in quadrant 2. In quadrant 3, tangent is positive. Okay. What about in quadrant 4? In quadrant 4, tangent is negative. Therefore, we will have two answers for this, for our theta. And that means if we are doing this right, the angle that we will get will be an angle in standard position, which would terminate in quadrant 2 and in quadrant 4. All right. So just keep that in mind. Now, we need to figure out the reference angle. And once we get the reference angle, we will try to figure out what the standard, the angle in standard position would be that will have that reference angle. Now, if you're thinking, okay, I'm sort of confused, so take it easy. Let's take a look at this. Tangent theta is equal to negative 4/3. All right. I'm gonna be doing this using a calculator first, and then I'm going to show you the math, sort of a graphical way of doing it. Okay. So if tangent theta equals negative 4/3, okay, use your calculator. Okay, use your calculator to find theta. However, guys, this is what I would like you to do. When you use your calculator, do not put in this negative. Okay? Now, if you're thinking, why? Because I want you to be getting the reference angle only. By doing this, you will be getting the reference angle from the calculator. And I'm going to be doing it myself, all right? So let me see. Um, okay. It took me a few seconds to do that. The tangent inverse of 4/3, not negative 4/3, is 53 degrees. 53 point something, which is about 53 degrees. Now, guys, remember, this is the reference angle. Now, our angle, the answer to the question tells us that it should be in quadrant 2 or in quadrant 4. Now, if our reference angle is 53 degrees and our angle would be in quadrant 2, all right? Theta is in quadrant 2. Therefore, to find the angle that we're looking for, it has a reference angle of 53 degrees. That would be 180 degrees minus 53 degrees. And that will give us 127 degrees. Okay? Now, another answer is we also know that it's supposed to be in quadrant 4. So if theta is in quadrant 4, what does it tell us? If it has a reference angle of 53 degrees in quadrant 4, it would be 360 degrees minus 53 degrees, and the answer would be 307. Okay? So that is just doing the math. Therefore, thinking, how do you do sort of a graphical solution, if you can call it that way? Well, what I would do is this. Since the tangent is negative 4/3, okay, and a tangent can only be negative in quadrants 2 and 4, all right? So maybe I can do this, okay? Now, tangent is opposite over adjacent, right? So maybe 1, 2, 3, 1, 2, 3, 4. Maybe I will do this. Oops. Okay, something like that, okay? And suppose that this is a right angle right here, okay? Okay, so okay, so there is your 4, there is your 3. All right, I know it's negative 3, but then in terms of distance it's 3, right? So the question is, what is this angle here? Know what I mean? Tangent of my theta would be opposite over adjacent. And if you use your calculator, all right, you will see, so in this drawing, tangent of theta equals 4/3. And you will see that theta will be equal to, hold on. All right, so guys, I'm back. I'm sorry, but the phone went off. I'm in the house right now, just so you know. I'm doing this late at night. Um, so anyway, I apologize for that. So let's go back. So I I tried to come up with a sort of a graphical way of doing it, wherein I created this picture. Okay, so your theta would be here, and opposite over adjacent would be 4 over 3. Therefore, to find theta, that would be inverse tangent of negative 4, or inverse tangent of 4 thirds, and that would be giving you 53 degrees. Now, as you can see, guys, the theta that I have in this picture is in quadrant 2. The theta is not the angle in standard position. Okay? The angle in standard position would be the angle that would be coming from here going that way. And since theta is 53 degrees, therefore, the angle in standard position would be 180 minus 53, which is why we got this. Okay? And then it's the same idea as you go to quadrant 4. All right? I just wanted to see if I can sort of give more meaning to it using a different way of solving it, which is like I said, sort of a graphical way of doing it. Okay? So hopefully that makes sense. Next one. So given that cosine alpha is equal to negative 4/5, and where is cosine negative? It is in quadrants 2 and 3. Determine the other primary trig ratios of the angle alpha. And to the nearest degree, determine the possible values for alpha when alpha is between 0 and 360. Okay, here we go. So once again, since cosine of alpha is negative 4/5, um, and that tells us that your angle can either be in quadrant 2 or quadrant 3. That means that we can do this. Now, guys, I'll give you sort of a tip, all right? This is a way of doing it. When I do it, as I look at a trig ratio, all right, negative 4/5, in my mind, I'm already telling myself, okay, that would be adjacent over hypotenuse. So in my mind, I'm already thinking about a triangle wherein the hypotenuse is 5 and then the adjacent side is 4. Okay. Now, if you're thinking, huh, how does that work? Okay, this is what I mean. I will be creating a triangle in the second quadrant for now because we agreed that since the cosine value is negative, that can only happen in quadrants 2 and 3. So let's just say that this is how it's going to be. 1, 2, 3, 4. Okay. And then I will have something like this. Okay. This is your 5. This is your 4. Okay. How do I know that? Like I said, the way I approach these questions, when I see a value like this, I'm already telling myself the numerator is the adjacent side, which is the x. The denominator will be the hypotenuse. All I need to know is this one, which will be the opposite side, and my angle is this one. This is angle alpha. All right. Now, for those of you who are good with the Pythagoras, you will know that y will be equal to 3. And how do you solve that? Y squared plus 4 squared equals 5 squared. Y squared equals 5 squared is 25 minus 16. That would be 9. That's why y is 3. Okay? Now, what would be the other primary trig ratios of the angle alpha if angle alpha is in quadrant 2? Okay? So in quadrant 2, so where do we put that? Okay, so let's just put it here. In quadrant 2, cosine of alpha is equal to negative 4 fifths. Sine of alpha, which is opposite over hypotenuse, would be what? What is the opposite side that we got? Oh, y is 3, isn't it? This y, which is the opposite side, we got its value or length, which is 3. That means the sine of alpha is going to be 3 over 5. Now, let me ask you this. Is the sine of alpha going to be positive or negative? In quadrant 2, the sine of the angle is going to be positive. All right? So, what else do we need? Tangent. Tangent of alpha. Tangent is opposite over adjacent. And the opposite side is 3. The adjacent side is 4. Now, we ask ourselves again in quadrant 2, is the tangent positive or negative? In quadrant 2, the tangent is negative. So there's your answer. Okay, so those are the three primary trig ratios of alpha for the alpha in quadrant 2. Now remember, since cosine of alpha is negative, that is also possible in quadrant 3. All right. So there is also this there's also this other triangle that we can probably draw that this time goes this way. Okay. And there is another alpha, this time going this way. Okay. There's your alpha right there. Now, this is also a 5. Therefore, this is also going to be a 3. Okay? Therefore, in quadrant 3, the cosine of alpha would be what? Negative 4 fifths, which is already given. And the sine of alpha would be also 3 over 5, except that we ask ourselves, what is the sign? Is it positive or negative of the sine ratio in quadrant 3? And it's going to be negative. Okay? While the tangent of alpha in quadrant 3 will also be 3/4 because it's opposite over adjacent, but we ask ourselves, is it positive or negative? And in quadrant 3, the tangent is positive. Okay? Now, so we've done letter A. Let's look at letter B. To the nearest degree, determine the possible values for alpha, meaning what are the possible angles? Now, guys, we already know we have two angles, right? So, what would you do here? To find those two angles, I will look for the reference angle. And once I get the reference angle, I will ask myself, what is the angle in standard position that would be in quadrant 2 that has a reference angle that I will find? And the same thing I will do for the angle in quadrant 3. So for now, let's do it this way. Find the reference angle, okay? The reference angle, meaning theta reference. Now, how do you do this again? You can use any of these trig ratios. You can use this, you can use this, you can use this. All right. I have always tried to use tangent. So this time, why don't I use cosine? All right. Why don't I use this? This one here. Okay. Now, so I will have cosine of alpha equals 4/5 or negative 4/5, sorry. But then guys, when we use the calculator to find the reference angle, we only do this. We don't do cosine inverse of negative 4/5. We do not do that. We only use the positive value because that's how the calculator is designed. All right. What is the cosine inverse of 4/5? So let's see. I will use my calculator. 4 divided by 5 cosine inverse. I got 36.869 da da da. All right. So that is about 36.8698. There's some more numbers. Um, I don't remember if it is asking to the nearest degree. Um, oh yeah, to the nearest degree. So 36 is about 37 degrees. All right. About 37 degrees. So alpha re- um, uh, reference, so the reference angle for alpha is what? Um, 37, about 37. Therefore, now, since alpha is in quadrant 2, that means our actual angle alpha would be equal to 180 minus 37, which is about 143 degrees. Okay? Now, since I also know that alpha is in quadrant 4, our actual alpha is 360 minus 37 is equal to, oh no, wait a minute. Is that quadrant 4? No, it's in quadrant 3. Okay. Okay. Let's just verify. Let's take a look at the top. Quadrant 3. Yeah, quadrant 3, not quadrant 4. Okay. Quadrant 3. Alpha would be equal to 180 plus 37, which is 217 degrees. So that wraps it up for this section. I know we did a lot of stuff. It is not easy, I get it. So I really need you to try your best to be able to understand this. At any time you feel that it's not making sense, pause the video, go back, and then watch it again. All right? So hopefully I was able to clarify things for you. Anyway, we'll also be having discussions in class. So I leave it at that. Thank you for watching.